And the first one is the principle of domain ownership here. And I think we talked a little bit about this of what is the size of the domain, which I think is going to keep coming back. It's roughly decided, it's a business domain. I'm really interested in, given that this is a scaling problem that we're trying to address here, what is small size, large size business domains, and how do they start breaking up as we start learning more about functionally? Let me go down. Why am I not? Excuse me. Okay. Oh, goodness. Am I? Oh, there we go. Oh, this is terrible. If I've used my mouse, we're going to be getting, well, I'll get watching the text fly by. Okay, so the principle of data as a product. Now, this one to me is really interesting in a sense of, you know, I come from an infrastructure background. I'm used to thinking about service contracts, and but you know, so I'm aware of, you know, what does it mean to say I'm going to commit to SLAs? But these terms here are difficult ones to in some ways to sort of say, look, if you're doing this ongoing as a service and you're talking about data, what does it mean to say your data is trustworthy and truthful? You know, it's a vague one. Like, I'm assuming it's trustworthy and truthful. Why do you have to call that out? You know, is it? Am I missing something there? But natively accessible. Well, okay, that makes sense. Yeah, sometimes again, the data domain, the business domain, the data domain is processing and shaping to produce something that has more concentrated value. But maybe what you want to sign up for is that raw, what do you have? And particularly when we start sort of worrying about, is this that operations data, or is that a data product that's something different? So I think this chapter 1 is sort of, you know, it's setting the stage. And I sort of took it as that to think, okay, you know, what kind of questions is this raising? Things I'm going to want to learn more about as we go through. But the SLA one I thought was fascinating. Is anybody else sort of any other reactions to this one in particular?
To the data as a product, myself, no. Granted, some of the terms are a little bit vague. But, you know, I think as someone who's worked in data for a long time, you know, a lot of these things resonate, even though they're vague. Like the concept of like trustworthy and truthful, like I mentally like decompose that into like, you know, these axes of kind of like, you know, let's call it like data governance in terms of like timeliness and quality. And
somebody sent him an email saying that he's not.
Yeah, so yeah, nothing specifically for this. Like the next terms you have you know, like highlighted, like data quantum is where it starts getting a little fuzzy for me, and I'd love to hear how other folks interpret that.
Sorry about that. I hadn't signed off on my other meeting.
More the merrier.
So when they say understandable, it's more like sorted, organized, the way whenever it's analytics, so it can reach up to the right data. Or if it is transactional, they would be more approachable. But I guess it's mixed of, you know, business terms and you know, the practically involved terms. That's why probably it's confusing. When obviously trustworthy and truthful is nothing, basically nothing. When we are talking about data as a number, and it's when we say it's data which is already polished, meaningful, then it's data. So it is trustworthy for someone, may not be me for me today, but it is trustworthy, it is meaningful, it is truthful. So I don't, somehow it's not relating here probably.
Well, I guess like thinking about like, and this gets into the meat of this whole concept, right, is like, as you think about the producers of data, you know, data in fact might be, you know, like philosophically trustworthy and truthful on its own, but like I'd say that the data product, if you can call it that, from most like data producers is not often, right? That's like one of the reasons that I think you know, this is compelling and resonates with people. So to me, like, data not being trustworthy and truthful is very understandable, and I think very common in our industry.
Wow. Cool. Let's see if I can get down to number 3. Oh goodness. Okay. Oh well, 3 and 4. Okay. So the self-serve data platform, I think, to me that feels it's an abstraction layer where it allows you to control. Hey, I've got data as a product. I'm going to be selective about things that I'm offering. I'm not just sort of opening up my storage platforms or data platforms and say, here's have at it what you want. I would say that's, you know, a difficulty on the data lake in some ways is that the idea was we said, hey, if we just shared everything, we'd be able to find great insights, and but it makes it hard to govern that thing. So I'm very interested in when we say the data platform, how are we selectively building out? Here's what it means when you, as the data producer, offer something to the consumer, and you've refined what those service levels are going to be. One of the challenges, though, in other words, there's one way to reduce the total cost of decentralized ownership, which was what Data Lake was trying to do. Open it up wide. Don't sweat the who has access to it in the governance. And that was a pretty, you know, low cost way of sharing. So reducing the total cost, it's I think to me there's an implied cost of what this platform is going to look like. Abstracting is always great, and to my mind, that's one of the great things too about the approach here is if you allow the data producers to define in business terms what they're offering. That's part of the argument of you know, trying to get the you know, abstract the technical layer so that the producers can describe it in business terms and increase the numbers of people who might want to use it. Automating governance, that one I'm really again intrigued by as well, because that, like I said, from my mind background, that's been the challenge with data lakes. You know, you can have quite a lot of them if it turns out that's the only way that you can sort of segregate pieces of it. Thoughts, questions? And number 4, boy, isn't this? Oh, sorry, did someone? Yeah, so number 4, you know, this is so here's my thought on number 4. The implication of federated is that it implies a natural kind of governance, right? You've got boundaries. If I have a federated environment and I'm in effect this data domain producer, I'm going to have some ability to trust others that are out there. I may not always know exactly who the person is when I federate an access to a group, but at least I have like a boundary implied there. So this one, again, it's I'm interested in how this sort of plays out. Because it's like, you know, and how we separate what does it mean to be federated and computational governance. Is that the computational in there is the one that's intriguing? Is it I need to have some metrics on how much I'm going to let you have, you know, given what my cost model structure is, maybe. And then we get to the picture. Let's see. And I did the math that I did on here. I was just trying to count in terms of, you know, the arrows out, the arrows in, and so okay, the ownership touches all the others, so it's got the valence of 3. And then when I'm setting up my data product, okay, yeah, I'm gonna update the service data platform. And I'm also going to have to worry about how does that product. This is a curious one to me, because I was expecting that the federated computer computational governance, that arrow might have been flipped. To sort of say, okay, yeah, here are the things you potentially can and can't offer as a data product. But then, the governance over toward the platform, yeah, obviously that one makes a lot of sense.
I actually don't like this drawing. I like the one after it better.
Well, oh yeah, right. Yeah. This is, well, I like the umbrella of this one too, right? It's like, that's how I think of governance, right? Is that it sits above. There are things that happen in the middle. The challenge with this diagram, in some ways, Lynn, is like, well, it looks a little like a 3-tier architecture to me, in a sense. It's just, and that's going to be the mix and the details of, how do you separate out that, the 3 in the middle, and by the way, what's the green one exactly?
Right. So just the way that I am working with this, just to overlay, is in Google Cloud, you have this idea of an organization, and this is now in Amazon, and I think it's in Azure as well. And the idea is for federated governance. So it's a top-level structure under which you create subsections for projects, whether they're analytics projects or operational projects or whatever. In Google, they are actually called projects. In the other vendors, they have different names. And I'm not going to say all the clouds because it's just too confusing. So in my world, you start with an org, and then you have projects, so the org would be the blue, and you would have certain organizational policies that would be inherited by each project, and that's how the federated governance would be implemented for data. That's how it is being done, basically. And in addition to what you inherit, the circles in the center, the yellow, green, and orange, those would be individual data domains in this case. They would then have their own specific governance based on whatever data is contained there. But there would be certain top level policies that could not be overridden. And this, I don't think, is actually new. I mean, in data warehousing on the cloud, this has been kind of a thing for a while. One of the things that is interesting about Google Cloud, just as a differentiator, is in between the organization and projects, you can put folders. And this really confuses people because most people think of folders as a place for files, right? Well, in GCP, it's an ability to sub-segment policies for sub-segmented federation. So you can have federation at the org level and then have more restrictive, but not less, at the folder level. And then beyond that, you can have more restrictive, but not less, at the project within the folder. And that is how my customers implement. And this is around data that has requirements for protection, so health data. So, so this is a kind of an extreme case. I've worked in a lot of domains where you don't have as much regulatory, but I think because I'm working with health data, this is not as new to me.
Did they push the security from the top level down, or is it defined at the lower levels? Oh, that's interesting.
Well, the trick, it's both. The trick is this: to define the minimum amount that is required for the organization, in this case for the meta domain, which human health care, right? And so this is defined by law for HIPAA in the United States, right? So the minimum amount at the top level, which is very difficult because you don't want to make it so people can't do their work, right? So the other aspect of this is to not just have two classifications of data. Don't just have public or patient. Have data classifications that mirror who's going to work with the data and what's going to be done with it. A common thing in health data, you de-identify it, and then it can be studied in aggregate by researchers. So having 3 levels at the very simplest way, which would be totally public, patient but de-identified,
Yeah.
or patient, right? And this is something that organizations are struggling with as they move to different environments, because most of the clinical organizations still keep the patient data on premise because they're, of just all these different reasons. So it's the world that I'm working in right now. So it's really, really fascinating. And it has these, I think, probably most complex security requirements. I've worked in fintech where there's a lot of security requirements because of federal finance law. But in my experience in the US, the most restrictive is health data, which is good, okay, but makes it a challenge to implement. Go ahead, Varsha.
So my question here is, when you say they are keeping the healthcare data on premise just because of the security reasons, they're not moving cloud?
Mm-hmm. Well, yeah, and a lot of hospitals are very slow to move to cloud because it's a high risk. You don't want to get it wrong,
Yeah.
So is that the reason? Still the hybrid is still a good concept, probably bringing up the cloud and on-prem together.
Yeah.
So security is the major for that factor.
Yeah.
Okay, and it's not the performance.
Yeah. So to contrast that, for pure research, where the data has already been de-identified and they don't have, individual patient records, that's an easier setup. It still has the federated governance because you have public data versus de-identified. But when you have actual individual medical records, that's, but again, you can generalize that to anything. So like your personal financial data, for example, that's another one that would have that level of governance.
Yeah, that's one. I'm interested in tracking that one as well, because to your point, you can de-identify the data, but if you can put just 3 or 4 sources together, you can figure out who it is.
Yep.
So it's so that's the other governance around. All right, yeah, everybody at the first level de-identifies it, but especially with medical data, right? It's like, look, there are only maybe so many people within this area that have these 5, characteristics or something.
I'm actually really familiar with this from work I did in on the AIDS crisis in Africa. It was we were one of the first DMRs in the world, like 10, 15 years ago, and it was run by US CDC and other groups. But although the law wasn't as rigorous, because the people we worked with were forward thinking. They really educated us in exactly that challenge. If data could be de-identified, what we would have to do to fully make sure that it couldn't, like literally do things like you do for encryption, like adding password salts and things like that to make the data more scrambled. But I'm not that up to date on law. I don't know if this is part of HIPAA. It should be.
No, I don't think it is. Yeah,
I don't think so either. I don't think we've reached that level of sophistication. But again, another area that I know I've had to deal with is COPPA, which is the children's data, which I don't know, Matt, if you have to deal with that. I would think you do from school.
Oh, we certainly do.
Yeah. So again, it's this idea of different levels of data that you have to have a certain security at the federated level. So I don't know, Matt, if you want to add something there.
I'm just trying to piece this into our realm. So for our student data, we basically have 2 major databases. One is all of our student grades, transcripts, classes. That includes disciplinary info. I mean, we have expelled kids. Kids have needed to be arrested because of certain unfortunate actions, but that's all in there. And that's stuff that it's very protected as to who we're allowed to share that with. And then we have special ed data, just the nature and nuance of it. That's in a different system. But again, we're dealing with very, protective information. We've got smattering of data in other places. But we are very stringent as much as we can, trying to dole those out to who's allowed to have access. That's usually role-based. The databases we're dealing with aren't sophisticated enough to really do true role-based security, but we do it ad hoc based off job roles. But what really intrigues me here is if we were to take those two databases and others and throw them in this type of model, how would we do that? How would we set that up?
Yeah.
You mentioned folders, and I'm intrigued, and hopefully we'll learn more later. But when I hear folders, to me, at least in my brain, that's like old school. Oh, we're going to put everything you need in this one folder and give everyone access to that folder. And it's like, well, wait a minute, because I need the same data accessible to other people. So in human resources or student data, you need phone number, you need name, you might need age, other things. And that could be given to a lot of people. But discipline should only be given to the counselors, the principals. It should also be given to the special ed folks. It should also be given to law enforcement. So am I putting too many people into this one folder in the one project because they all need different reasons for the data? Am I duplicating the data across multiple folders? And this is where I like role-based security and some of the other fancier terms. It's like we're tagging the data almost. The data is in one place. It's kept up to date by one set of people, but I can give you access to it based off the tags, not necessarily because it's segregated specifically. So I'm interested to see how they would tackle those types of problems.
Yeah, my expectation to where you were pointing to is multiple copies of data with things removed makes it easier to manage some of the privacy security, because I can say, look, if you get all the way down here, you've got access to everything, right? But I know based on your role, you only need these things here. So I'll give a data set that only has the things you want. And then I just have to worry about, well, how do I keep that updated? And, you know, how do I, you know, is batch going to be good enough? But yeah, that's one way to solve it, I suppose. All right, let's we talked about this before, but because I think this is going to keep coming up in terms of this artificial distinction between, well, it's operational data, if it's the implication raw, potentially a data warehouse, but you know, I think she has to keep sort of coming back to this as well in some ways, because some of that operational data is valuable to other units in the business. And the other way it might be valuable is if I come up with a cost model that says I'm a data domain business owner and I'm producing these data products, I've got to figure out a way to allocate my cost of operations across those products. And so someone might start being interested. Well, wait, can you tell me, like, what was the churn rate? You're eventually you're cost allocating something to me that's been refined. I might be interested in what was the operational data and compute and storage that went behind that came out with that pricing, because that's something I might, you know, or internally, I think this, the implication right now is, sure, the domain has to worry about this, but yeah, what happens when your data product is raw data? Because you know that's what that other business unit really needs to do, because they're going to do things with it that you hadn't thought about. And then I think we're just about, oh yeah, of course, then the analytic data and yeah, and this is an easy teardown, right? We're not talking about a data warehouse right now, and even within data lake, I think data lakes, the idea of well, let's just all put it in raw and do schema on reads later. Well, the nice thing about data warehouse is if you think about it in process and frame it up, you get much faster results than if you're always trying to read it raw and put it together. So it's you know, I don't think the data mesh is arguing against any particular technology, but again, we talked about this before. It seems like a little bit of an artificial distinction.
Yeah, I don't like this one. You know, and it even kind of like you know, talks about, well, like, I think there's a diagram, we didn't stumble upon it, where they talk about, like, well, sometimes operational data is a data product, and yeah, I just think the artificial distinction is counterproductive. But I don't know, I think to me, like, so much of this resonates with DDD and event-driven architecture and everything, that I just see it all like kind of coalescing. And yeah, I won't make, we'll keep talking about this one, I'm sure, but it's not my favorite for distinctions.
And if I'm not mistaken, I like this just because it was paradigm shifts. You know, that's always kind of fun to talk about. And I was involved with someone who was studying the history of science and got a PhD. So a lot of it's like, oh, I know this stuff. You know, this is fun. And these are certain, and I like this framework too, because it's as she's presented it. It's very easy sort of to relate back to. It's a nice model to say, start focusing on the anomalies, which is another way of saying, some things are hard, and should they be hard, or is the hardness starting to accumulate to a point where she points out, if you're spending all your time trying to fix the hard in order to move forward, something's wrong. So it seemed like this would be a good one to go in with, to a company, and if they're just talking about all the exception stuff that they're processing and whatnot, this is like to me, a nice model to say, maybe you're ready for a large transformation. And in the YouTube, it seemed like that's where they reached, right? They didn't come to DataMesh first. They were trying a lot of things that they just couldn't get around. Yeah, and let's see. Cool. Yeah. Zero trust. I wasn't. Throwing zero trust architecture in here right now is like, it seems a little early. I'm not sure it fits yet, but we'll see.
All right. Well, I think if you feel like got through one, I'm going to go ahead and jump in if that's all right.
For sure.
All right. So I'm going to go ahead and see if I can share my screen here. All right. And I just want to. Okay, why system preference? I got a new laptop, so of course it's telling me I have to say that I can share my screen. So let me see how I do that. Okay, so system preferences, and I am in Chrome, so plus. Sorry, guys. And what am I supposed to be sharing here? Zoom? Any thoughts on this?
Oh, let's see. I wound up going with my whole screen, but
right. But it's because I got a new laptop. Oh, maybe I have to just say Chrome. I'm going to have to leave and darn it. I'm going to have to leave and start again. So I'll leave and come right back.
Okay.
She comes back. I can't remember. Elliot, were you the one who has an Azure background?
No, not me. Very little Azure, actually.
There was someone in the group who had an Azure background. So they were going to come at this well, Lynn was coming at this from a Google side because that's what she's working with. Someone said, they could do it from an Azure side.
Yeah, I recollect, but I can't remember who.
I'm interested in that just because we're an Azure shop.
Okay, it's still recording. Let's see if I can share now.
Oh, wonderful.
Share your screen. Yeah, that's a good feature. Good job, Google. Okay, so now it lost all my tabs, of course, that I had open for you guys, because, that would be too much to do. All right, so the first thing, whatever. The first thing is I want to just show you, because when I was looking at the reference architectures, the Amazon one, I think, was just more relatable. This is in the associated resources. And if anybody wants push access to this, just email me and I'll give you, because this isn't just my repo, this is our repo. So just to kind of get us kick started on this, both Google and Amazon have released products within the last 12 months to support data mesh, which is, again, one of the reasons I'm so interested in it, because generally, particularly when Amazon releases something, there's enough demand in the market that there's starting to be adoption. So Amazon's product is called Data Zone. It's a set of services. And what I like about their reference drawing here, it's not really an architecture, is it really helps to start to give you a picture of what they're thinking about in their services. So you can see you've got a number of different inputs, whether it's buckets or relational databases or whatever. And then you have this concept of a catalog, which is not new. And then you have a set of services. So this is really the key part right here, that the services move from individual services that operate on, I would say, a subset of their products to more expansive. The Glue catalog becomes the business data catalog. So it's like a superset, basically. Notice here, it's sitting on top of this set of services is sitting on top of Amazon's OLAP the service, which is called Redshift, and Lake Formation, which is their set of services that are designed to sit on top of buckets. Because again, this is analytic workloads. So this is the inputs coming from all your operational stores. This is sort of the current architecture before Data Zone of how you would put this into a data warehouse, and you would catalog it for the data warehouse. And this is an expansion to include both your data warehouse and your data lake. And then you have consumers over here, and then a set of services that helps with the areas like federated governance and discoverability and data as a product. So first of all, does this kind of make sense? Are there any, again, this is new to me too, so we're all learning together here, but is there any questions or anything you want to share about this?
I think I like it. The one thing that seems missing to me, and I know I mentioned before, like kind of my bias towards solving this problem so far, is that it's all very like kind of batch and like data sets and like redshifts and S3 buckets and everything versus, yet addressing the modality of event-based data. But the components make sense, and having looked at this product myself a bit, I do like the concept of projects, and I think it's well conceived, like how you'd interact with them and how you'd leverage them. So
Yep. Another resource before I jump into the Google stuff that I've been finding really, really helpful is this architecture site that has patterns. So what I really like about it, and again, sorry, I had this all loaded, of course, is I'm a sort of a visual thinker. And so it has a bunch of patterns that start from, I would consider it as they augment what is presented in the book with a little bit more detail. So, we haven't got really to data product yet, but they have, actual data product cards, and they start talking about implementations. So I feel like this is kind of a glue between the book and the cloud vendors that I'm using. So I wanted to have that as a resource as well. So now let's go to Google Cloud, and we'll get into the beginning of a demo here. So their set of services is called DataPlex, and I have multiple projects set up for demo. But before we do that, I want to kind of, again, talk about the problem space from my perspective. So it should be obvious by looking at this page, this is a little demo account, what the problem is with buckets. It's just a really common problem before you even get to data lakes if you're doing files as data, which is the world of genomics, which is bucket sprawl, because you very quickly get a random list, no matter how hard you try, of bucket names that are not usable and not searchable. And this is sort of the classic problem of data swamp. This is, even in a demo point, this is what it looks like, right? You have bucket sprawl. So Google has had a set of services, kind of like Lake Formation, to address this, but they have not been as fully fleshed out before DataPlex. So Amazon, in my opinion, was a little bit ahead in the implementation of a lake, and Google was more in the level of raw buckets. So working in the Google ecosystem, I'm really hoping that DataPlex can help to address this, because particularly in genomics, where we use like no operational data, we use buckets, it's a huge problem that we just have hundreds or even thousands of buckets. So what does DataPlex look like? When you first go into DataPlex, it looks like, I call it Google for your data, which, it's on the Google Cloud, right? So you can see it literally looks like Google with a bunch of things that are data in this particular project. Now, again, in case you don't happen to be so familiar with Google Cloud, this is the concept of these individual projects. So if I switch projects, you know, that would be a different project, and then I could go ahead and I could search, which this is, in my mind, the implementation of discoverability, that you have all this thoughtful metadata, which we will not get time to cover completely today, but does include tagging. You can see over here, tag, 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 to Matt's point of, I want to tag the data. But the result for the user, when you are the consumer, when you've done this thoughtfully, is they can have a Google for their data. And notice that their data can be tables, but this is a little bit confusing because this does not mean like OLTP relational tables. It means something else. Data sets, models, data streams. This goes to Elliot's point of what, you know, does Amazon account for event scenarios? Because events scenarios use streams. And I think that Google's offering here comes out nice and strong with this, because this will actually index your pub/sub streams, which is kind of cool. So one of the first things, of course, is what are all these things, right? And I'm still working on that, because, you know, it's just so awesome not when vendors take concepts that you know what they are and rename it. So you don't know what it is, but just
Or reuse common names for different things.
Yeah, exactly. So the other thing I guess I should show you a bit here is what is the data work? What's the redshift of Google Cloud? Some of you might know, but you know, again, it's maybe not as well known. It's BigQuery, and BigQuery is very different conceptually than Redshift. Redshift started as, you know, server-based basically, and it now has a serverless component. But BigQuery has always been serverless, like from 2011. So basically, you have different interfaces, but what you're working on is you are running SQL queries against data that in its internal implementation is implemented as columnar storage. So in an OLAP kind of storage. But it's a lot more, you're not getting into like the level of detail you get into with Redshift. The promise of BigQuery is literally that you have your data set and you just click run and you pay by the amount of data that was queried. So it's like $5 a terabyte or something like that. So you just literally see bytes build. That's why that says that. So truly a serverless service. So one of the things I bring to the table is I was an early and still am a very frequent user of BigQuery, because honestly, it's kind of delightful. You know, look, ma, no servers. Now on the other side of it, there's a tremendous learning curve, because of course, like all things powerful, it's not as simple as it seems. You need to set up your tabular structures, which under the hood it is a type of bucket with files, but it's a schema on read. So you have to either infer or define the schemas, and you have to partition, and there's all kinds of things. There's modeling that you have to do, but there's not servers. There never has been servers. So it's a fundamental difference. And in the analytics world, in my opinion, it's a strength, which is one of the reasons why I'm interested in DataMesh on GCP, working with BigQuery rather than Redshift, because I'm comfortable with it. So you do have areas to work in here, and those are called data sources. And once you have a data source, then inside of the data source, and let me pick one of the ones, you have the ability to make data sets. And data sets can be a lot of things. That's where we kind of come back to this idea of DataPlex being able to work with a lot of things. At a high level, DataPlex works with buckets or BigQuery things. So again, not to get too in the weeds, just like AWS Data Zones works with buckets and Redshift tables, right? But it appears to me, and to be fair to Amazon, I have not dived into Data Zones, so maybe they support the breadth of things that DataPlex supports, but it appears that DataPlex supports more types of data objects, event streams, for example, BigQuery machine learning models. As far as I know, and as you can hear by listening to me, it's hard to keep up with all the products across all the vendors. BigQuery has an extension to SQL that allows you to do machine learning within basically a query inside of BigQuery. As far as I know, Redshift does not have that yet.
Redshift does have it. It's pretty delightful too.
Oh, thank you. Thank you.
Yeah, wraps SageMaker and SQL syntax.
Okay, perfect, great. So the important thing is to go beyond buckets and tabular structures for OLAP, because it's more than that. The details are going to vary by the vendor product. Okay, so now I'm going to go back over here. So I'm going to just close this out so we can look at a high level. So what do we have in DataPlex that's greater than just the search capability? Well, we have the Discover, which is search based on filters that are presented within this API. We also have a more sophisticated type of search, which is called Explore. And if we open up Explore, what we then have is we have the ability to run, again, SQL queries, but it's really interesting that notice what language you're running it in. You're running it in Spark SQL. And the reason for this is you're using Apache Spark as a query engine. And the idea behind this is you can query across the different object types in your environment. So going beyond BigQuery. But again, you're not as bothered by the details with this. It's basically search, or if you want to go beyond these filters, explore and write a SQL statement, and Google will handle the implementation details for you. So this is the findability aspect.
So they're using Spark almost as a data virtualization product.
Yep.
Yeah.
Yep. And notice that you have other environments too that you can use. So anyhow, so that's the Discover. And then really the next thing that I would work on would not be the catalog, but it would be the lake. So the idea here is that because of bucket sprawl, that you would probably want to take some of those raw buckets and add that layer of lake management. And again, I think this is a difference in product release times from Amazon to Google, because as I was saying earlier, Google really didn't have this functionality as fully flushed out before DataPlex, whereas Amazon had it with what it's called Lake Foundation. So this is very integrated inside of here. So the idea is that you would create a lake, and then within that lake, you would use a Metastore service. So this goes all the way back to Hadoop. So I've been doing Hadoop for a long time, but I realize a lot of people have not. This is the schema on read of Hadoop, where you have the Hive Metastore. So you use managed Hadoop, which is called Dataproc in Google. It's called Elastic MapReduce in Amazon. And this is your schema, because when you are elevating files and buckets to something that can be queried and read through the set of services and managed, you need some concept of schema. And the idea here is an integrated storage for this schema. And so it's a Hive Metastore. So when you create a lake, you say if you want a Metastore or not, but you basically do. And then once you have a lake, then inside of the lake, you create zones. And the types of zones that you can create are raw or curated.
Ah,
And that comes directly out of the book.
Yeah.
Yeah. So, so the idea here, as it says, raw, is store data in any format. And this is useful for data requiring further processing. So this is the idea of genomics would be a really good example. You get the data off the genomic sequencers, and that's in a certain file format. And then what you do always in the next step of processing is you compare that data to a reference genome, and then you get another file called a VCF file, which is the variance of interest between the particular sample you have and the reference. So in other words, you start with the raw data, and then you go through a process, and then you would get the curated data. So to make an example from genomics, you would put the FASTQ files, they're called. Everything's proprietary, doesn't really matter. And then you would put the VCF files, FASTQ's in raw, and then you would put the curated files in, the VCF files in curated. Notice the structured data must conform to certain file formats and be organized in Hive compatible directory layout. And this is so that it can be queried.
Question on the raw. Does this carry with it the concept that you never delete on the raw, you just add records rather than updating?
I don't know. That's a good question. I don't know if it's defined. I don't.
Yeah, okay.
I don't think it is. So once you have a zone, then notice, because certain assets would require certain actions based on how you've set this up. In this raw zone, I have some action required here. So if I go into this raw bucket, so this has an actionable error. I think it's around the governance. But yeah. So on my schema, basically, I put in some junk schema just to get it going. Yeah, see, invalid field name. So I'm still exploring this because, when you first read raw, my initial thought was you can throw anything in there, right? But maybe because I put a Hive metastore on this lake, you can't in raw.
Yeah.
Again, these are the things I'm learning, right? But right now, this bucket, even though it's raw, it needs schema that actually works. Yeah, so again, there's lots of knobs to turn. Do you know what I mean? Lots of fun with this. So
You try this with the curated zone. Does it work with curated?
So with curated, I think I put a schema in here so that it would work.
Okay.
So notice, yeah, so notice you have discovery, so it indexes it, right? And then you have governance, depending on what you've set on this. So again, like I said, this is really an introduction to this, but to me, this helps make the book more tangible when I try to work with a vendor product. So I can go, okay, I'm thinking of, what would be in a raw zone? What kind of governance would be in this particular subset of information, right? And we have some sort of concept of managed. So that's probably what I'm missing here, right? Notice on the zone, you have permissions. This is actually really, really important because you can put different resources in the zone, and those resources would be, buckets, BigQuery assets, so on and so forth. And you assign permissions at the zone level at the top, but then you can do it at the tag level more granularly, right? The whole idea is rather than putting the permissions on the bucket, which again, if just nothing else from today, everybody knows people get bucket permissions wrong all the time. And it is a big problem because it's the wrong level of granularity. So anyway, so you can see DataPlex propagates policies in the DataPlex hierarchy, lake, zone, asset on an ongoing basis. So the idea is to manage it by function, which some of the other stuff in this is taking me a while to see the business value, but this I can immediately see it. Because, I mean, seriously, in, I don't know, 10 years as a cloud consultant, I can count on one hand the number of customers that have bucket permissions, right? They just get it wrong all the time. I mean, you see it in the news, you know,
Yeah.
big consulting firm puts wrong permissions on S3 bucket and customer information is fully exposed, right? I think it's because we come from a database background and we think of permissions in terms of databases. I think that's why it is, but it's sure done wrong. So to that end, when you secure, notice you can do resource or principal centric. So, and here's the lake and here's the zones. And then you can see data permissions and asset permissions and audit logs. Again, I'm still getting into all this, but I look at it and I think this seems very promising. Like I really want to dive into this, probably because my scenario is super high security, right?
Yeah.
And then just to round this out, we have a process section, and this is fascinating to me. This is as we get into the book more. This is the idea of putting the code with the data. So the microservices idea. And so I have really just been playing around with this a little bit, probably more the next time. But, you know, you can see just from the names, you know, ingest, convert. So this is like ETL, but it's associated to the data. So this part's really, really new to me.
I wonder how, like,
Wow.
yeah, no, it's the first time seeing all these things like together, you know, because like I think I mentioned that like the quanta seemed a little like some of it made sense, but some not. Yeah, so this definitely helps. I just wonder, like, almost if you back out from like a persona perspective, like if you're trying to, it seems very, very much like a centrally administered essential tool, but we talk about like federating, right? So like, would we imagine the persona of all those distributed data product owners coming in here, and what would the tool look like to them, and what would their responsibilities be?
I know. I know. Well, you know, one of the things about segmenting, I'm so glad Matt brought it up, is there's all these different kinds of templates. So there's these default templates, and the easiest one to understand is geo context. But there's data quality, and you know, you can make your own. But then there's policy tags, and then there's entry groups, and then there's glossaries. So there's 4 different kinds of, and see, these are actually big query policy tags. So there's 4 different kinds of metadata, and I'm still really trying to get, I think the book is going to help with this because this is really kind of new to me. And then in addition to this, there's an attributes store, and there's the ability to profile and check data quality. So I've spent less time in these areas, but this to me is the really new, but I just haven't seen it like you're saying, Elliot, all together. So anyway, so I told you that it would be a quick tour, but I if you're like me, it kind of just like the two together makes it more interesting. It takes the book out of the theoretical and starts putting it into the practical a little bit more. Like, how do I use these tag templates? What do I, like you were saying, Varsha, like what do I put in the raw zone? Like, how do I set that up? So my commitment to the group is I'm going to continue to work on my demo and figure some of these things out and then kind of give you updates. Yeah, and I'm serious about using the repo too, because if you guys want to use that, that's totally fine.
I'll take it. I'll take 2.
Okay, thank you. I appreciate it. So I just want to kind of keep going at this slow pace. But if that doesn't work for you, let me know. So thank you, Elliot, and thank you, Norman, for presenting.